So I am recording. All right. Okay, so last time I presented the AC method, as it's called. And remember, this method allows you to factor a polynomial that looks like this. It's actually a generalization of what we do over here. But here it actually is less steps because A is 1. Okay, so for this polynomial here, right, the AC method, assuming A is not 1, this is the procedure. Now it's in the lecture notes, so of course you don't have to, you don't have to memorize it. But again, the whole idea is this. You're multiplying A with C, right? Excuse me, first you find, and then you factor out the GCF. You know, that's what you do first. Then, once you do that, you find the product of A times C, and you want two numbers, okay, whose product is A times C, whatever that is, but the sum has to be B. The sum has to be B. Then, what you do next is you replace B with that sum. What will happen is you'll get a polynomial with 4 terms, and you could apply factor by grouping. So I figured today it'd be good to do more examples, and that's what I'm going to do. Okay, so here's the first example we're doing today. Now, notice right away, we have 3 terms. However, the degree of this thing is 3. That is, the highest power of x is 3, x cubed that is. So at first it looks like we can't use that AC method, but let's factor out the GCF and see if that helps. Let's find the GCF of this polynomial and factor it out. So right away you can see that the smallest exponent of x here, it is 1, right? You know, that's over here, x to the first. And now let's also look at the coefficients, okay? So if you look at the coefficients, we have 30, 25 I put here, and negative 155. I mean, really, you don't need the negative, okay? But now when you were to list all the factors, as you can see that 5 is the greatest common is the greatest common factor of the coefficients here. 5 is. Okay. I mean, 155 might be a little bit tricky, but it is doable. But you can see, though, that 5 is a factor of it only because the last digit is 5. You know, if a number's last digit is 0 or 5, then 5 is a factor of it. I mean, how do you know that? That takes a little bit of work. It's actually beyond, I think it's number theory, but that's a different story. But either way, we get the greatest common factor of the coefficients is 5. Okay. Good. All right. Okay, so from there, what we get is, get that, and we get this, that the GCF is 5 times x to the first. You know, B is what the 5 is over here. That's what the greatest common factor of the numbers is. And we have is 1, so we get 5 times x. So that's great. We know what the GCF is. Well, let's factor it out. And that's what we do here. Okay. So it's just like before. We have it in front. Then we divide, as you can see, to find out what's left. And it's the same story. When you divide you divide into each term, okay? Okay, now let's go to the next slide. Once you do this, okay, the first quotient you'll get, right, 30 over 5 is 6. X cubed over x is x squared. That's how we got this. By direct calculation, 155 over 5 is just 31. X squared over x is x. 25 times x over 5 times x is just 5. Okay, so we end up with this thing. Here, right, we can use our AC method on this, 6x squared minus 31x plus 5. Right, we can do that. We have 3 terms, and the degree is 2, so that's good. That's what we want to do. Okay, so that's what we're going to do next. So this is just what we had over here. 5x is factored. We're left with this. Okay, so again, just like last time, we really want to know what A, B, and C are. I mean, I will list them, but really from here, you could probably see it just by comparing. Namely, we have A. Here, let me actually get the pen. Oh, no. Okay, we have, right, A. We have is 6, right, just by comparing coefficients. B, you should be able to see is negative 31. You always want to include the negative. C, as you can see, is 5. So we have A is 6, B is negative 31, and C is 5. So even without listing it, hopefully you can see just by comparing them visually. And in this AC method, what we do is we have A times C, which in this case is 30. So we want 2 numbers whose product is 30 and the sum is negative 31. Okay, so that's what I have written here. I was going to say it again, but it's written out here. Okay, so again, 2 numbers, right, whose product is 30. The sum has to be negative 31. And here I'm just being consistent with the notation from before, right? We just want to fill in the blank, so to say. Now, 5 and 6 alone, their product is 30, but they're not going to work, right? 5 plus 6 is not going to work. The sum of 5 and 6 is 11. It's not negative 31. So we can't use 5 and 6. But you might be able to see, you might be thinking though, what about 30 and 1? Well, 30 times 1 satisfies this condition here, so to say. Its product is 30, but the sum is not negative 31, it's 31. So it's close. 30 and 1, no, doesn't work. But you can see they're pretty close though, right? I mean, we don't want 31 here, we want negative 31. Okay, so what about, that should tell us, how about negative 30 and negative 1? And that's going to work. So that's going to work, right? By our sap and sun rules, sap signs alike positive, sun is signs unlike, then the answer is negative. So here we get negative 30 times negative 1. Okay, this is 30, and the sum is negative 31. So these two are going to work. Good, good. All right, that's good. Okay, so we have our numbers. Next, what we're going to do in the next slide is we're going to replace negative 31 with negative 30 plus negative 1, as you can see. And that's what we got to do in the polynomial. Okay, that's what we're going to do in the polynomial. Okay, so let's do that. Right, so again, what am I doing here? Negative 30, I'm replacing that, excuse me, negative 31, I'm replacing it with negative 30 plus negative 1. Okay, and there's an x here, right? So I'm keeping the x over here. And now from here to here, what do? I distribute. Okay, in other words, I'm going to do this. I'm going to distribute. So here we get negative 30 times x, and we have negative 1 times x, and which is the same as this. So I replaced negative 31, right, with this sum, and then I distributed x, as you can see. That's all I'm doing. Okay, again, I'm emphasizing it. I think it was, I'm not sure if it was this class or the other class. It doesn't really matter because I think some people were confused by this. That's why I'm showing more steps. Okay. In fact, let me just have to pause it because I have to stop and start the recording.